Okay, good evening. Uh, Students who are online, can you hear me clearly, please?
Yes, we can.
Thank you. Okay, so this is week 8. Welcome back from the reading week. Let's talk about term test 2. Term test 2 is on March the 12th, and we'll start at 9 o'clock to 11:30. It'll be 2 hours, 30 minutes. It will be face to face, and it will be held in this room, which is Bird Size Building 106. Topics to be covered will be whatever that I've taught you from week 5, week 6, and today, week 8. I will provide formula sheet, okay? So anyone, any question? Anyone? Say it again. Yeah, will be this classroom alone. Oh, how many questions? Sorry, questions will be either 2 or 3. Okay, question will be either 2 or 3. Now, the thing about face-to-face, the questions will be very similar to your homework. Okay, about 10 to 15% change. It's going to be the question. You've seen it from your homework. Are we clear? Okay. Right. If I don't have any questions, let's look at the agenda for today. We are going.
Sorry, are we allowed to have a formula sheet you said? So we can bring our
I
own?
will generate the. I will provide the formula sheet.
Oh, okay.
Then what will happen is, on Monday, you all will see the formula sheet. Okay.
Are you gonna upload the answers for the quiz?
Yes, I will be. Okay. Any other questions, please? No? Okay, I will start. So today's agenda will be on sandwich material. Then we are going to look at eccentric symmetrical loading, and then centric unsymmetrical loading. Okay. So on sandwich material, I will teach by showing you an example. Okay, so example on sandwich material. And I have uploaded examples on Avenue to Learn. Can you please download the examples, please? Okay. So I'm going to get the question. As I said, you can get this on Avenue to Learn. All right. Let me string it up a bit so I can write. So what you see over here is a structure. The top plate is made up of aluminum and is enforced with Kevlar 49 plastic beam. Okay. So if I'm going to sketch this or label this, this will be our aluminum. And the surrounding will be our Kevlar. So determine the maximum stress in the aluminum and in the Kevlar if the beam is subjected to a moment of 900 pound-feet. Okay, so we are given a moment. The moment is going in the anti-clockwise direction, and it's at 900 pound-feet. So you need to do 900 multiplied by 12, and then you will get. Excuse me, I need to get my calculator. Sorry. So 900 times 12 will be 10,800 pound inch. Okay. So to do this, so this is what we call a sandwich material. Basically, any material made up of two different materials. Okay, so the formula that we're going to use, okay, will be stress X is equal to N, okay, multiplied by MZ over IZZ multiplied by Y. So this is our equation 1, and this is for sandwich material. So everything is the same, right? Is this N over here? What does it mean? Okay, what does this thing mean? So N is equal to Young's modulus of material 2 divided by Young's modulus of material 1, where material 1 is the reference material. And what is the reference material? Okay, so you will ask, what is the reference material? Reference FER. Okay, what is the reference material? And I would say you decide. Okay, you pick what you want the reference material to be. Okay, so E2 is the other material. Okay, Young's modulus. Same thing, Young's modulus. So you decide. Okay, so as I said, we will do this as an example. So for this example, I've decided to choose aluminum as the reference material. Okay, so we have selected aluminum as the reference material. And I'll also mention to you or show you what does this physically, what does this means, okay, when we pick aluminum as the reference material, okay. So in order to use aluminum as a reference material, we need to know the Young's modulus, okay. So Young's modulus of aluminum will be equal to 10 to power 10.6 times 10 to the power 3 psi. And then you have Young's modulus of Kevlar, and this will be equal to 19.0 times 10 to the power 3 psi. Okay. So for this example, we decide to use aluminum as the reference material. So when we are going to find any stresses in the aluminum, the formula that we're going to use is stress X for aluminum is equal to N aluminum MZ over IZZ multiplied by Y. And any stress in the Kevlar will be stress X Kevlar is equal to N Kevlar mz over Izz multiplied by Y. So the difference is these two coefficients over here. Okay. So how to get that coefficient, right? So we are going to apply this formula over here. Okay. We're going to apply that formula over there. So N for aluminum will be equal to Young's modulus of aluminum divided by Young's modulus of aluminum. So this is equal to 1. Okay. Why we divide by aluminum? Because we select aluminum as the what? Reference material. Okay. And then for Kevlar, is equal to Young's modulus of Kevlar divided by Young's modulus of aluminum. So this will be equal to 19 times 10 to the power 3 divided by 10.6 times 10 to the power 3. Okay, so 19 by 10.6 is equal to 1.792. Okay, so we have both our N value depending on whether we are going to calculate the stresses on the aluminum or the Kevlar. Okay. So the next thing that we're going to do is, what does this physically actually means? Okay. I'm going to pick aluminum as the reference. What does it actually mean? Okay. So if we look at the original structure, okay, if we look at the original structure, so I'm going to sketch this out. So the original structure is this, okay? So it's 6 inches in height, 2, 4, 6, and it's 12, 2, 4, 6, 8, 10, 12, and the next 1. Okay, and then you have the vertical piece coming down, you have a horizontal going across. So this is the original geometry. Okay, this is the original geometry. So as I said, on top is aluminum. The rest of the part I'm going to highlight in yellow. Oh, wrong thing. I'm going to highlight in yellow. These are all our Kevlar. Okay. So when we introduce the formula, right? When we introduce the formula N mz over Izz multiplied by Y as equation 1 for sandwich material, and we pick aluminum as the reference material, what did we actually do? Okay. So what we impose is this. The aluminum did not change in size. Okay, so I'm going to draw the aluminum with its original dimension. Okay, this is aluminum's original dimension. Okay, so this is still our aluminum.